So, my name is Alex Dubovoy. I work for a company called Averity. I'm a recruiter. I did this meetup specifically to not recruit people. I wanted this to be done by engineers, for engineers, and me hang out in the back and have a beer and chill and enjoy this thing. We got two amazing presenters. Namely has been a host for us. I think it's the third time that you guys have hosted, and every time they've been absolutely amazing. So thank you to Namely, Alcide. Thank you to CircleCI for putting this whole thing on. Thank you to Namely for feeding us and buying us beer.
Really what I want to talk about is how you would combine Kubernetes and Vault, which are two very strong API-driven products. API first, basically, allows for great automation. How do you combine these things and how do you make them useful? Vault is a really great security product from HashiCorp, and they do a great job with using the open source version and making it pretty featureful. There's a million ways to authenticate. There's a million things that are related to security and secrets that it can do, and it's pretty human friendly as well. So it's a pretty good fit for a lot of places, especially if you're trying to consolidate secrets, which is something that I recommend for a lot of places because secret sprawl, configuration sprawl is a real thing. One of the things is like a default Kubernetes installation is, I mean, depending on how you set it up, I think, but like by default, it's kind of wide open. It's like, depending on how you map your users to your RBAC policies. In general, there's people execing into pods. There's you're going to be adjacent to the namespace of Vault. Like you can use node selectors to kind of isolate Vault from the rest of the cluster, and you can tighten down your RBAC and all that other things. But like that's a lot of extra work. But if I put it outside the cluster, I can like turn off SSH, and like no one's going to get into it. There's no way that people are going to intercede in this secure center for all of my good stuff. They have a lot more replication patterns if you have the enterprise version. It allows you to filter like certain data. So like let's say I had like a central vault and I wanted only certain subsection of keys to go to a different vault cluster. They can do that. When I came to Namely, there's like over 100 microservices running in production. And like I was not going to go around asking the development teams to like change their applications to allow Vault to work with it. So one of the goals when migrating to Vault was like, hey, let's not make this a pain for everybody. So I wanted to do it in a way that if the application was expecting certain things to be fulfilled, Vault would do that kind of behind the scenes, and then the application would start and everyone's happy. It's good to understand the line of responsibility between whenever SREs, DevOps, whatever you call them, maybe they're responsible for like that database host or that password or whatever. How the devs are expecting to consume information from the DevOps SRE database teams. Like, what's the handoff? We have promotion of our configuration values and secrets through lower environments. And so if you have a way by which you review these things and you have values and that people sign off on them and then suddenly they're put into your configuration stores, we wanted to allow that to still work where maybe a microservice repo has the values that it wants to use, and then we promote them and then they get put in. We wanted to allow devs and people to still have that workflow. So just because we're moving to Vault doesn't mean we want to get rid of the capabilities that devs have in controlling the way that their applications work.
If you were to look at your Kubernetes, whoever is running like EKS, GKE, or whatever, the number of times that your Kubernetes API server is being probed, and if you're not monitoring that using kind of an AI engine or something, or at least you know what to query around the API server, it's constantly being probed. And oftentimes, if you think about the amount of automation running in your cluster, operators, highly privileged components, controllers, highly privileged components, how do you know that something didn't kind of breach or running inside your pod? It basically can access the API server and potentially take over the entire cluster. So this component pretty much, when you think about your security stack for Kubernetes, you start from resource hygiene, runtime defenses, and then covering the infrastructure through the audit. With Kubernetes, when we are using Helm charts, or we are using mutating admission controllers, or we are using label selectors, effectively, what's really happening in the cluster depends on how this rendering occurs. So let's take a very simple example with network policies. If I'm to configure network policies that says every pod that has the red label, would be associated with the network policy. Now, all of a sudden, one of the human users would change one of the annotations of the pod. So Kubernetes automatically will kind of deassociate the network policy. So essentially, we broke an assertion about a certain workload, and if this is a PCI compliant environment, we pretty much kind of became non-compliant with the environment. So that pretty much covers why CD actually matters in the sense that we scan the cluster after the deployment, not the actual resources. Operators are another good example. As someone, again, coming from the paranoia side, I don't like operators. Why I don't like operators? Because these are persistent, normally highly privileged components that are running in the cluster. So oftentimes, I mean, if you want to go and fetch something periodically, it makes sense to kind of implement it as using a job that basically spins up when it needs to run, and then kind of being killed once when it doesn't need to run. Controllers, on the other hand, will pretty much keep this component persistent in the cluster. And again, normally, if you scan kind of the RBAC permissions of all those charts that we deploy, most of them have cluster roles associated, either read or read-write. And again, from a security standpoint, extremely bad.
This is what it takes to define orgs at the top. That's it. So I've got Alcide as an org, GCP, GCR, K8S, SNCC. SNCC is a scanning tool. So that's how easy they are to define in the CircleCI environment. And these are our jobs, and each of these jobs could run in parallel. So we can do the build and test of the Docker, scan it, that gets put up, and then we do the push the image out in order for it to be deployed. And then here is the Alcide part. So once we have it out, and we right above that is where it's being deployed to Google Cloud, we just tell Alcide, hey, go take a look at this container that's just been started in Google Cloud and do an analysis of it, and then generate the, where is it at? Oh. It generates an HTML file that it will upload so you can take a look at it as a report. So you have an audit trail of anything that may have changed in the security posture of this container. I think we have that.
We have that in the archives.
There we go. And that's it there. So Alcide gives you this nice compliant security personnel friendly view of what your container is and how vulnerable or not vulnerable it is. And all of this is possible because of orgs being configuration as code combined with your code for deployment. And what did I do? Oh, there we go. And it runs at whatever step. At CircleCI, we want to get out of your way. We just want you to be able to do whatever job and the style you want to do it. So we try to make it configuration agnostic, style agnostic, whatever tools you need. Now, this is a simple demo. It has a lot of steps. They all run in sequence. In a more professional environment, you'd have them as parallel, storing artifacts or caches, so that way you're not rerunning every step every single time. So you can get your entire testing set up as a parallel sequence, and it may only take like 5 to 10 seconds to run. And then you're on to the deploy check. The advantage of tools like Alcide is that you can do, at every transition, you can do a security scan that's appropriate for that point. And then once everything passes, it goes into production. Or if you're running a sandbox, it goes to the sandbox and then you can promote it. And using our workflows feature, you can actually have that promotion be gated by a human. So that way, before the container actually goes from sandbox into production, security personnel has to go in there and say, okay, I'm going to let that workflow run. And then it'll go on through. So depending on how paranoid you are, you can control the environment.